Alright guys, so we are going to continue with dividing radicals here. Let's start by simplifying this. The cubed root of 8 over the cubed root of 16. Now, the process is still the same, even though our index is different this time, an index of 3, the process is still the same. We can rewrite that as the cubed root of 8 over 16, which simplifies to the cubed root of 1/2. We're then going to split it back into two parts, the cubed root of 1 over the cubed root of 2. And now we need to rationalize the denominator. Now this time, because my index is 3, I can't just multiply it by 1, cubed root of 2. I actually need to multiply it by 2 cubed roots of 2 so that I have 2 cubed and a cubed root, and they'll cancel each other out. Now you can write that two different ways. Here's how it's going to look in the example here. You can write that as the cubed root of 2 squared. The other way that you could have done it, you could have actually written cubed root of 2 and cubed root of 2 and then cubed root of 2 and cubed root of 2. Okay, because we're dealing with an index of 3, we need to make sure that we have 3 2's under that radical symbol so that it will be rationalized and come out from the radical symbol. All right, once we've done that, we multiply across the top and the bottom, and our top becomes the cubed root of 2 squared, which is 4, the cubed root of 4. And then the bottom, we've got 3 2's, 1, 2, 3. We're taking the cubed root of 2 times 2 times 2. Okay, the cubed root and the cubed exponent, they all cancel each other out. We've got a group of 3 here, so the 2 comes out, and we're left with just a 2 on the bottom. Okay, let's simplify this one. 18a squared bc squared divided by the square root of 9ab cubed c cubed. First thing we want to do is write that as one fractional radicand, and then we start simplifying. When we simplify our 18 and our 9, 18 divided by 9 is 2. We simplify our a's. We have 2 a's on top and 1 on the bottom, and that will simplify to just a. Our b's will simplify. We've got 1b on the top and 3 on the bottom, and then those will simplify so that we have 2 left in the bottom. And then c squared over c cubed, those will simplify to 1c on the bottom. So we're left with 2a over b squared c. We're now going to rewrite those as 2 separate pieces. So square root of 2a on the top here, and then on the bottom we've got the square root of b squared c. Now, b squared c, taking the square root of b squared c, that square root canceled the b squared, and the b comes out. So that's how we got to this point right here. If you want me to write that out in prime factorization, that was b times c, and our 2 b's came out here. So we're left with 2a, root 2a over b square root of c. We're still not done because we need to rationalize the denominator. So how do we get rid of a square root of something? Well, we square it. So we're going to multiply that by root c. Whatever we do to the bottom, we have to do the top, which becomes square root of 2ac over bc. Final answer. All right, so in this first part, we divided expressions that contained radicals. We're going to pick back up on the second part. It's going to continue to look at radicals and different ways that we can rationalize the denominator. All right, so this is now the beginning of part 2. We had to overflow a little bit of part 1. When rationalizing the denominator, what that means is we're manipulating our fraction to get the irrational number out of the denominator. And that's what we've just spent all of part 1 doing. So 1 divided by the square root of 2 has an irrational denominator. To be in simplest form, the denominator cannot be irrational. So that denominator cannot have a radical in it. We also said that you could not have a radical with a fractional radicand. That also does not work. And so in order to simplify both of those, we did have to rationalize the denominator. We multiply both the top and bottom by a root. So in 1 square root of 2, that's an irrational denominator. We're going to multiply both the top and bottom by the square root of 2, so root 2 over root 2. Because square root of 2 times the square root of 2 is... Alright, so I'm having some technical difficulty here, and I think I've been cut off I'm not sure what I was saying just a second ago, so I apologize if this part right here is kind of glitchy, kind of cut me off there. But this is just a review of rationalizing the denominator, so let's try 3 examples on your own. Pause the video, try these, and come back to check your work. Alright, so this first one, we've got a root 3 in the bottom. We need to rationalize it by multiplying both the top and the bottom by the square root of 3. And when we do that, we get square root of 3, and then square root of 3 times square root of 3 is just 3. So square root of 3 over 3 on the bottom. All right, we are going to do number 2. We've got to multiply the bottom here by square root of 2 to rationalize it, and whatever we do to the bottom, we also have to do to the top. So when we do that, we multiply across the top. 3 times the square root of 2 is 3 square root of 2, and square root of 2 times square root of 2 is just 2. That 3 got left off there in the slide, but it is 3 square root of 2, and there's no way to simplify that. All right, 3a over square root of 6, you multiply both the top and the bottom by square root of 6. So that becomes 3a square root of 6 over 6, but we've got 2 coefficients here in front of our terms that can be simplified. 3 divided by 6 is just 1/2. So that's 1a root 6 over 2. We don't have to write the a, so it can just be a root 6 over 2. But sometimes it's not that simple. Here's an example of a fraction that has an irrational denominator. But instead of just one term, like we've seen before, we now have 2 terms. Remember that terms are separated by plus or minus signs. Terms are not separated by multiplication and division, but plus or minus signs. So we've got 2 terms here. And we can't just rationalize the denominator by multiplying by root 2 like we've done because we've got 2 terms. So the way that we're going to rationalize the denominator when there are 2 terms here is by doing something called multiplying by a conjugate. So the conjugate is where we change the sign in the middle of the 2 terms like this. So if our first term was 3x plus 1, our conjugate is 3x minus 1. So we just change this sign. The reason that we're going to do this is because when we multiply conjugates, we get something called a difference of squares. So if we were to FOIL this out, first, outside, inside, last, and then we were to combine like terms, what we would get is a squared minus b squared, a difference of squares. Please notice that this is subtraction once you multiply it out. And all it's done is taken the first term and squared it, and the second term and squared it. Now you could FOIL it out. If you FOILed it out, you would get a squared minus ab plus ab minus b squared. And what you see here is that your minus ab and your plus ab, they cancel each other out. So you're left with just a squared minus b squared. So when you want to rationalize a denominator that has 2 terms, we're going to multiply by the conjugate. And our shortcut there is just take the first term and square it, minus the second term squared. Let's practice multiplying some conjugates before we go. Now, we could, again, FOIL, but we could just look at these and go, oh, these are conjugates. They're the exact same terms. The only difference is the signs are opposite. And when I multiply conjugates, I'm going to take my first term and square it. And then I'm going to subtract my second term. 3 times 3, 9. All right, try number 2 and 3 on your own. Pause the video while you try it, then come check your work. And hopefully you recognize these are conjugates as well. And so according to our pattern, our difference of squares, we're going to take our first term and square it. And then subtract our second term squared. We're going to take our first term and square it. Okay, we could write that as 2 squared a squared or 4a squared. And then our last term, we're going to subtract that squared. Underneath my handwriting, you'll see all of those. To rationalize a binomial denominator, you're going to multiply both the top and the bottom by the conjugate of the denominator. So, like before, what you do to the bottom, you have to do to the top. Binomial just means 2 terms. So to rationalize a denominator with 2 terms, you've got to multiply by the conjugate. Multiplying both top and bottom by the conjugate of 3 minus root 2 is what we're going to do with that previous example that we just saw. So we had 1 over 3 minus root 2. We're going to multiply both the top and the bottom by the conjugate. Remember, anything divided by itself is 1. So we're really just multiplying this by 1. Okay, then we're going to take on the bottom, our first term squared. So there's our first term squared, and then our bottom term squared, or our b term squared. So here's our root 2 squared. At the top, we may have to distribute. If this is anything other than 1, we would multiply 1 times 3 and 1 times root 2, which is just 3 plus root 2. Okay, the top cannot be simplified. These cannot be added because they're not like terms. However, the bottom, 3 squared is 9. And the square root of 2 squared, those just cancel each other out, so that becomes 2. 9 minus 2 is 7. All right, so let's continue and try one. 2 over 5 plus the square root of 3. We see that we have a binomial, 2 terms, so we can't just rationalize the denominator by multiplying by root 3. We do need to multiply by the conjugate. The conjugate of 5 plus square root of 3 is 5 minus square root of 3. Whatever we do to the bottom, we need to do to the top, so that this equals 1, so we're just multiplying it by 1. And we're going to take the top and distribute that, so we have 2 times 5 and 2 times the square root of 3. And then on the bottom, because these are conjugates, we can square our first term, 5 squared, and square our second term, square root of 3 squared. Let's simplify. 2 times 5 is 10, and 2 times the square root of 3 is just 2 square root of 3. We can't simplify that anymore. And then 5 squared is 25. And the square root of 3 squared, remember that these just undo each other, leaving us just with 3. So 25 minus 3 is 22. We then can reduce because this has a common factor with 22 and this has a common factor with 22. So we can, basically, all of these can be divided by 2. Another way we can do that is split that into 2 fractions. 10 over 22 minus 2 root 3 over 22. We practiced this at the beginning of the year. 10 divided by 22 reduces to 5 over 11. And 2 root 3 over 22 reduces to 1 over 11. So minus root 3 over 11. And because they have the same denominator, we can put them back together in this form. 5 minus root 3 all over 11. All right, now this one's a little bit more intense. Okay, a little bit more work that we have to do. We do have a binomial on the bottom, so we are going to rationalize it by multiplying by the conjugate. So we'll multiply both the top and the bottom by 3 square root of 5 minus 1. So here's the conjugate that we're multiplying by. We're going to take the top and we are going to distribute. And then we're going to use that special difference of squares rule that we practiced for conjugates on the bottom. So we've got 11 times 3 square root of 5 minus 1. We take our first term and square it. So we have 3 times the square root of 5 squared. And then our second term minus our second term squared, minus 1. Let's continue to simplify here. 3 square root of 5 squared. 3 squared is 9. And square root of 5 squared is 5. So that's 9 times 5, which is 45. And 1 squared is just 1. So we've got 45 minus 1 here on the bottom. Notice that I haven't multiplied out just yet. Okay, there's a reason for that. When I take 45 minus 1, I've got 44. And because they haven't multiplied out, I see that this 11 and this 44, we can simplify those. 11 over 44 is the same as 1 over 4. 1 over 4. And when we multiply 1 by everything to get rid of the parentheses, nothing changes. So we're left with just, let's drop those parentheses, come back. So we are left with 3 root 5 minus 1 all over 4 as our final answer. No parentheses there. Now you could have multiplied out. You could have had 33 root 5 minus 11 and then simplified at the end. You would have gotten the same thing. Okay, let's try some on your own. Pause the video, try these on your own, and then come back and check your work.